Okay, what I'll do is I'm going to show you how to read the book, and I'll show you how to interpret the material. I'll also go over things like hot and cold currents. I'm going to talk about the Gulf Stream, the Labrador current, the Greenland current. We're going to talk about El Nino, wacky weather they call it, climate changes. Now, let's begin, shall we? Okay. There are 3 projects that are due in 1 week from today. Okay, 1 week from today. So they're due next Thursday. There are 3 projects. The first project is going to be they're all posters. They're posters. The first poster is you want to map ocean currents. Now, all the major currents. Understood? You map on a poster. You're going to have to make a picture of the world. And what you can do is, I'm no artist, trust me. I'm not an artist. You can cut things out from books or photocopies of the continents of North America, South America. I am no artist. I wouldn't expect to be able to draw them, but you can do that relatively easily. So that's the first one, map of the oceans. Okay, understood? And I'll tell you the other 2 as we progress through the material today. Okay? Now, so we have off the coast of Canada, we're using the New Brunswick curriculum. Off the east coast of Canada and the eastern United States, you have several currents. I'm going to make a very terrible map of North America. Okay? All right, that's North America. Terrible map. And here's Greenland somewhere up there. Understood? Here's Canada, the United States. Clear? And over here is England and Ireland. Clear? Now, there's a current that goes like this. Okay? And that's called the Gulf Stream current. That's called the Gulf Stream current. That brings up very warm waters from the southern latitudes. Goes off the coast of Florida, very close to South Central Florida. Palm Beach County. In Palm Beach County, there's an island just off the coast called Singer Island. And it comes very close to Singer Island. So it comes very close to the eastern part of Florida and goes up and moderates, severely moderates the weather in Ireland and England. Even though Ireland and England are very high latitudes relative to Canada, they're relatively mild winters. They're more mild than New Jersey. Let's say that's New Jersey. More mild than New Jersey. Or about the same. So they're very far south of New Jersey. They're very far north of New Jersey, but they have fairly mild winters. So it helps the climate of Europe, Western Europe. You also have the Labrador current. Now the Labrador current comes off Newfoundland. That's the Labrador current. It comes between Greenland and Newfoundland, which is north of New Brunswick, Canada. And then you have the Greenland current, which comes down like this This is Greenland. Okay? Comes down the eastern side, and they're cold currents. Now, when the northeastern edge of the Gulf Stream is actually called the NAD. On chart, you see it labeled NAD. It's called the North Atlantic Drift. That's the northern end. These are warm currents. Let's make a distinction and call these blue. These are blue, cold. And these are red. And then the North Atlantic Drift. Okay? And Iceland is in there. Iceland, Iceland is round, yes? And the northern part of Iceland is in the Arctic area. Just the very northern tip, the Arctic Circle. Just the very northern tip. You would think that Iceland would be completely in the Arctic area, but it's actually not. It's south of the Arctic area. North, very far north, but it's south of there. It's actually quite a nice place from what I hear. They have nice hot springs. You can go swimming in the winter because they have a lot of volcanic activity. They have a lot of hot springs all throughout the country. Supposedly a very nice place to visit, winter or summer. Okay, so that is on the currents. So these currents will transport icebergs. Have you ever heard of the Titanic? Yeah. What current do you think carried an iceberg down and met the Titanic? I'll give you a hint. The Titanic hit an iceberg, I believe it was somewhere off the coast of Newfoundland. It was coming from England. What current do you think probably brought the iceberg? What current? The Labrador current, the Greenland current, or the Gulf Stream?
Greenland.
Well, it could have been. The Greenland current kind of wraps up like this. The Greenland current kind of goes like this. So it may not have been the Greenland current. Could have been, absolutely. We don't know, really. But it was probably the Labrador current. The Labrador current kind of goes down, meets the Gulf Stream. You get a warming of the Labrador current, a cooling of the Gulf Stream. So it was probably the Labrador current brought the iceberg down from the north. Probably, but who knows. So those currents will transport icebergs. Okay? Let's talk for a moment about the El Nino. Okay? I'm going to draw a terrible picture of North and South America. You ready? Here's North America. Here's Central America. And here is South America. Okay? That's North America. That's South America. Okay? This is Central. You get the idea? Okay? Yeah. Now, here's a place, this is important. Here's a place, the equator runs like this through Ecuador. Here's a place right here. I think it might be actually here. It's around there. It's called Kiribati. It's where it's famous because it's where the date changes. Where does tomorrow begin? Tomorrow begins there in Kiribati. They kind of rearranged that time zone. So it's Kiribati. That's where the time zone changes. Tomorrow begins in Kiribati. Understood? Okay. So there's a strange thing that happens right here. It kind of goes over towards the international date line, Kiribati, north central South America, and it's a shallow effect. It's called the El Nino effect. That's where you get this unusual warming of the top surface layer of the Pacific Ocean, east central Pacific Ocean, and might actually be more central like that. And you get this warming, and it warms the top portion of the water, unusually warm. Now, let me give you some numbers. The numbers really won't mean anything to you, but when I put both numbers on the board, you can compare them. .18 grams, 4.18 joules per gram degree Celsius, 0.45 joules per gram degree Celsius. Those are the specific heat capacities of water and iron. This is water, and that's iron, Fe for iron. The specific heat capacity of water is 4.18 joules per gram degree Celsius. Am I on? Am I on?
Yeah.
Okay. Iron is 0.45 joules per gram degree Celsius. Specific heat capacity at constant pressure. That is the specific capacity of a substance, pure matter, to raise 1 gram of substance 1 degree Celsius. Joules is a measure of mechanical energy. Okay, no big deal. You don't have to, just know, that's just a given. Okay, definition. That's all. Joules could be peanuts, doesn't matter. So it takes 4.18 of these funny things called joules. You don't need to know how a joule is organized, you don't need to know anything about it. Is that alright? Have you ever heard calorie? Well, it's sort of like calorie. It's just a measure of energy. Okay? 4.18 joules to raise 1 gram of water 1 degree Celsius. Clear? It only takes 0.45 joules to raise the temperature of 1 gram of iron 1 degree Celsius. So, what's the lesson? This is it. You ready? Water can hold 10 times more energy than an equivalent mass of iron. 1 kilogram of water on my left hand. 1 kilogram of iron here. Yes, this is full. This is full. Same temperature. I have 10 times more energy here than I have here. Isn't that amazing? All that energy, what does that do? That literally changes the climate in most of the world to some degree. Isn't that amazing?
Yeah.
Where do you think hurricanes, typhoons come from? It comes from warm water, storms over the ocean. The ocean heats up. The water evaporates. It goes in the clouds. Low pressure. If I take my hand and go like this on a feather, the feather's going to go up, right? Because I'm reducing the pressure, right? If I take a little tissue, I go like this, and I go like this. It's not doing anything. But I go like this, see what happens? Look, it's lifting. If I take a piece, give me a piece of paper. Find a piece of paper. just need a piece of paper. I'll show you. So that evaporation reduces the pressure. So it's called low pressure. You form the clouds, rotation of the earth. You get this cyclonic motion of the clouds. You form storms. I'm going to reduce the pressure on top of this paper. You ready? What happened? Yeah, it rises. Okay? Yes? So when I have this enormous volume of water heated, that's literally going to affect the world. I'm going to tell you why. What are the normal winds? I'm going to erase this. Is that okay? I'm almost done. Here's the earth. Okay? Here's the equator. Okay? What do normal winds look like? Right in your book. When you look, page 383, what do they look like? You get this warm surface water here. It's going like that. Remember, it's spinning like this, right? Yes? Here's Australia here. That's Australia, right? This is South America here. This is what's happening. This is normal. The warm surface water goes from east to west, right? Yes or no? Right? Then this is normal. And then in the El Nino year, it goes like this. Wacky times, dude. Wacky times. Good times. Okay? Now, what do the trade winds look like in a normal year? Trade winds, what do they look like? Trade winds are like this. You ready? Let's use blue. Trade winds are like this. Okay, those are trade winds. These are normal. Trade winds. It goes from east to west. Yes? These are called trade winds, right? Trade winds. These are called trade winds. Yes? And then what do? During the wacky years, what happens? During the wacky years, it goes like this. It's not this far north, guys, but this is wacky. This is the wacky year. This is the El Nino year. Okay? You get it? So the trade winds go east to west. East to west during the, let's make east on the other side. Go east to west. East, we're saying that's east to west. That's normal. This is normal. These are the trade winds. Right? But then they go west to east when the El Nino. Okay? You want some extra credit? Make a separate poster about the El Nino and how it specifically changes the weather in the world. That's some research. Want some extra credit research? You got it. Understood? Goes from Maisha too. I know you're home. Hello, shouldn't feel well. My best to Maisha, okay? Easy? Yes or no? Are we done? Okay. Now, before we end, I want you to map separate poster, map wind currents. Okay, that's your second map. Understood? Wind currents. Understood? Separate poster. Not on the same poster. Understood? Yes? And then we will. We're going to do another film, but we'll make this stop. Okay, good?